Section 1.6, classifying polygons. Let's start by defining what a polygon is. A polygon is a closed plane figure. What it means by a plane figure is that it lies on a flat two-dimensional surface. What it means by closed is that there's nothing left open. So something looking like this would not be a polygon. Something like that would be a polygon. The sides of a polygon are line segments. Specifically, they're line segments that are connected at their endpoints. Where those endpoints connect are called the vertices or a vertex of the polygon. So again, a vertex is where a side connects with another side in a polygon. There are two types of polygons, convex and concave. I gave you pictures for you to see a visual. The book goes into a big, long description of extending each side of the polygon and seeing if the extended side goes into the interior of the polygon. If none of the sides go into the interior, it's convex. If one or more of the sides goes into the interior, it's concave. I think the easiest way to remember the difference between convex and concave is that in concave polygons, one of the sides caves in to the rest of the polygon. Next, we'll start naming some polygons. A three-sided figure is called a triangle. A four-sided figure is called a quadrilateral. This trips kids up a lot. They'll think that a four-sided figure is a square or a rectangle. Those are just types of four-sided figures. A blanket term for anything that has four sides is called a quadrilateral. And literally, quadrilateral means four sides. Quad means four, and lateral means lines or sides. So four sides, quadrilateral. A five-sided figure is called a pentagon. A six-sided figure is called a hexagon. A seven-sided figure is called a heptagon. An eight-sided figure is called an octagon. A nine-sided figure is called a nonagon. A 10-sided figure is a decagon, like a decade is 10 years. And notice that we skipped 11. There is no commonly accepted name where everyone agrees on what we should call an 11-sided figure. So we'll move on to 12. A 12 is a dodecagon. The way I remember this one is do, like dos in Spanish, is 2, and then decagon means 10. So 2 and 10 is 12, so dodecagon. Just like with the 11-sided figure where there is no commonly accepted name for it, there's no other names after 12 that everyone agrees upon. So if you want to refer to any sided figure, an n-sided figure, you're going to call it an n-gon. For example, if I wanted to refer to a 14-sided figure, I could just call it a 14-gon, a 19-gon, a 21-gon. They just keep going on just like that. Next, let's talk about how you can classify a polygon according to its sides and angles. First, equilateral. Dissecting that word, we get equa and lateral. Just like when we talked about quadrilaterals, lateral means a line or a side. Equa would mean equal. So an equilateral polygon would have all congruent sides. Next, we have equiangular. Dissecting that word, we have equa and angular, so equal angles. An equiangular polygon would have all congruent angles. A polygon can be equilateral and equiangular at the same time. If this occurs, it is referred to as a regular polygon. The picture that I've provided, as you can see right here, has tick marks on each side of the polygon, meaning it's equilateral. It also shows that each angle is congruent. So therefore, this would be referred to as not just equilateral, not just equiangular, but a regular polygon. Specifically, there are 5 sides, 1, 2, 3, 4, 5. So that'd be a pentagon. So we would classify this as a regular pentagon. Let's look at our first example. Tell whether each figure is a polygon. If it is, tell whether it is convex or concave. So part A, I see 5 sides. Each side is connected. None of the sides are curved or anything weird is happening, so this is a polygon. And specifically, we would call this a convex polygon because none of the sides cave in on each other. Part B. Again, we're looking to see if any of the sides are curved or Some of the endpoints don't come together at each vertex, but this does happen here. And you can see here, we actually have numerous sides that cave in. We have this side caving in, this side, and this side, and this side, and this side. All of those are caving in. So yes, this is a polygon, but we would classify this as a concave polygon. Example 2, classify the polygon by the number of sides. Tell whether the polygon is equilateral, equiangular, or regular. So part A. First, I notice that we have some tick marks. We have that this side is congruent to this side, but we are not told that the third side is congruent to the first two. So it's not equilateral. Then I see that this angle is congruent to this angle. Just because these two angles are congruent to each other does not mean that the third angle is congruent. So it's not equiangular. Therefore, it can't be regular. If it's not equilateral and equiangular, a polygon cannot be regular. A three-sided figure like this one is called a triangle, so I would just call this a triangle. Part B. First, let's just count up the number of sides. We have 1, 2, 3, 4, 5, 6, 7, 8 sides. So we know it's going to be an octagon. And then I notice all of these tick marks. Each side is marked with the same tick mark, meaning that all sides are congruent. I also notice that each angle is marked as congruent to each angle, so therefore it's equiangular. So remember, if we have a polygon that is equilateral and equiangular at the same time, that polygon is regular. So we would call this a regular octagon. Part C. First, I see that there are 4 sides, so I know this is a quadrilateral. Next, I see that all 4 sides are marked congruent, so therefore I know this is an equilateral quadrilateral. However, I also notice that the angles are marked. This angle would be congruent to this angle because there's 1 crescent, and this angle is congruent to this angle because there's 2. However, all 4 angles are not congruent to each other, so it is not an equiangular polygon. So therefore, the only way we can classify this is as an equilateral quadrilateral. And finally, part D. After counting up the number of sides, I see that there are 12 sides, so this is a dodecagon. I also notice that all of the sides are marked congruent with tick marks, so it's also equilateral. And then I notice that all of the angles are marked as right angles. A right angle would be congruent to another right angle, so therefore this is also equiangular. Since this polygon, this dodecagon, is equilateral and equiangular at the same time, this is a regular dodecagon. Our last example, number 3. A rack for billiard balls is shaped like an equilateral triangle. Find the length of a side. So dissecting this problem, I see equilateral. Equilateral means that all sides are congruent. So I'm going to mark each side congruent to keep that in my mind. I'm given 2 sides as 4x plus 2 and the other is 6x minus 4. Again, knowing that all of the sides are congruent, I know that 6x minus 4 would be equal to 4x plus 2. So that's how I'll start out my equation. 4x plus 2 equals 6x minus 4. I'm going to subtract the 4x so I can keep this side positive. So 6x minus 4x is 2x. And then I'm going to go ahead and add the 4 to get 6 equals 2x. Divide both sides by 2, and we get x equals 3. Remember, it's asking for the length of a side. So now all we have is x. Knowing that x equals 3, we can now plug that into either side, the 4x plus 2 or the 6x minus 4. Since the sides are equal, it doesn't matter, and we should get the same answer no matter what. Let's just pick the one that maybe looks a little bit easier, 4x plus 2, and substitute that 3 in for the x. 4 times 3 is 12, and 12 plus 2 is 14. So each side would be 14 inches long. That's it for this section. Let me know if you have any questions tomorrow in class, and we'll see you then.